Solving inequalities. Step 1. We would like to have 0 on one side of the equation. In step 2, we write the other side, which is not 0, as a product of terms. In step 3, we are solving each term to be 0. Example: x to the power of 2 minus 2x equals 3. Step 1. We get x to the power of 2 minus 2x minus 3 equals 0. Step 2. We are writing x to the power of 2 minus 2x minus 3 as the product of x minus 3 times x plus 1. We need now to solve each term to be 0. From x minus 3, we will get that x is 3, and from x plus 1, we will get that x is negative 1. The answer to this equation is x equals 3 and x equals negative 1. Solving inequalities. We are going to show how to solve inequalities by an example. Here is an example. X to the power of 2 minus 2x is less than 3. In step 1, we will write 0 on one side. In step 2, we will write the expression x to the power of 2 minus 2x minus 3 as a product of terms. In step 3, we are going to do what we call analysis on the real line. This is analyzing x minus 3 times x plus 1 to see where it is positive, negative, and obviously where it is 0. We will start by finding the zeros of x minus 3 times x plus 1. The two zeros are x equals 3 and x equals negative 1. Now let's go from left to right. At x equals negative 1, the expression is 0 because x plus 1 is 0. At x equals 3, the expression is 0 because x minus 3 is 0. This divides the x-axis to 3 sub-intervals. One of them is between negative infinity to negative 1, then the other is between negative 1 and 3, and then the other one is between 3 to infinity. We know from algebra that the expression x minus 3 times x plus 1 can only go from negative to positive or positive to negative if it is first of all 0. This means that the sign of the expression x minus 3 times x plus 1 is the same on the first interval between negative infinity to negative 1. It is the same between negative 1 and 3, and it is the same between 3 to infinity. But even more than that, if each one of those sub-intervals has exactly the same sign all over it, then it's enough to check only one sample point. For example, I'm going to substitute negative 2 into this expression. If it is positive, then it is positive all the way between negative infinity to negative 1. And if it has the other sign, then it is also the same between negative infinity to negative 1. So let's do that. We get 5. But the truth is that I don't care about the numerical value. I only would like to check if this is positive or negative. In this case it's positive, which means that it has to be positive all the way between negative infinity to negative 1. Now we are going to check the sign on the second interval between negative 1 and 3. 0 is a good sample point. We are now substituting in the expression x equals to 0, and we get negative 3 times 1, which is negative. Between negative 1 to 3, this expression is always negative. Now we are going to check the last interval, that it is between 3 and infinity. Here is a good sample point. We will substitute 4, and we get that it is positive. Now we really care about Answering the question, the inequalities say that the expression has to be less than 0. We observe and we see that between -1 and 3, this is strictly less than 0. And we get the answer that x is greater than -1 and is less than 3. Example: solve the equation x to the power of 2 equals 25. Here is step 1. Here is step 2. X to the power of 2 minus 25 is x plus 5 times x minus 5. We are solving each one of the terms to be 0, and we get that x equals -5 and x equals 5. Be careful now. You are not allowed to take the square root of both sides of the equation. This is a very common mistake. Don't do it. The reason is the square root of x to the power of 2 is not x, but this is x in absolute value. Because of that, the square root of 25 is 5. So if I will do this mistake, I will get that the answer is only x equals 5. The reason is because y equals square root of x is not the inverse of the function x to the power of 2. As a rule, the square root of x to the power of 2 is the absolute value of x. Example: solve the inequality x to the power of 2 minus 25 over x plus 2 is less or equals to 0. Step 1. It's already done. Step 2. As before, x to the power of 2 minus 25 is the product of x minus 5 and x plus 5. Now we have to do the analysis of the real line, and we have to note that x cannot be -2. It's very important for the analysis because now you will see what I'm doing at -2. So we will start from left to right. At -5, this expression is 0. -2, I do like a star, like a no, impossible. I cannot include this number into my considerations. And then at 5, the expression is 0. Now I need to take sample point of each one of those subintervals. Be careful. Even though -2 is not 0, when you see we have 0 and the no star and another 0, it means that we have here 4 subintervals that have to be checked. The sign of the expression of x minus 5 times x plus 5 over x plus 2 can be changed when x passes through x equals -2. At -6, it's negative. So it's negative all the way on this interval. Here we plug in -3, we get positive. And we also have to check on the other side of -2. We can take 0 as a good sample point, and it is negative. And in the last subinterval, we take 6 and we get positive. And here's the answer, because you can observe that we really like to take all the x's for which this expression of x minus 5 times x plus 5 over x plus 2 is less or equals to 0. Here is the answer written in the interval notation. This is the most common notation that is used in calculus. -infinity to -5 including -5, and the other part is -2 does not equal -2 to 5 including 5, or all the x's which are less or equal to -5 and x's which are greater than -2 and less or equals to 5.